Let's talk about schema. Schema is a declaration of all the data structures that your project uses. All the APIs that you're writing or the APIs that you're consuming, they will have input and output messages. And you'll be declaring those structures here. Plus, what ZOAPIIO does is it abstracts several other aspects of your application also as XML nodes. And they appear here in your schema. When you start a new project, you get these things by default. For example, your application session is abstracted, and that's what you see here. You create schema under all of these nodes pretty much in the same way. Even database tables will appear in the schema. And how internally those structures respond functionally is managed by the system. So today, let's just see how to create schema, right? And obviously, the starting and the simplest way is that you just go to a node, go right click, access the context menu, and say new tag. So the response node that you see here is by convention, right? There's no compulsion. I mean, it's just by convention that all the services you're writing, their structure should appear under this. Similarly, this web service, and the convention is all the services that you're consuming, their request and response structure should be declared under this. And request represents the HTTP request. That's where you declare the request for the APIs that you're writing. Okay, so we created this first node and have to give it a name because data elements have names. Then there's a data type. And these are the basic data types that are supported. You should pick a right data type because, again, how these nodes will functionally respond will depend upon the data type that you assign here. If you leave it blank, it will default to string. System will assume it's a string. Then there is a flag here you can set which says duplicates, which means that what I'm declaring here is actually an array of elements. So that means multiple instances of this element can appear in your data at runtime, and you can access them using an index. There's another flag here which says key component. Okay, now this allows you to create an array which works as a hash table. That means it can be accessed not just by an index but also a key. So typically, you would create an element, and inside that you would create sub-elements, and there one of them you will assign a key component. So when you're accessing this, you can use that value, and it will access the corresponding element of the array, which is actually which functions like a hash table. XML namespace you would use if it's an XML node and your structures are XML namespace sensitive, right? So this is relatively less used because XML is less used, and even in XML, some APIs don't care about the namespace. The size and the required options, they are purely for documentation. System will not enforce these constraints. And you can obviously give some comments to remind yourself what it is. Okay, now, so this is if you're creating a large structure. For example, if you have an API that you're creating, and a typical structure has something like, it may have hundreds of elements, including the sub-elements. So creating all of that by hand is obviously is not recommended. And what you would do is you would use a tool provided here, which is one of the tools here. One is import from XSD, import from a sample XML, or import from a sample JSON. So typically, if you have designed your APIs, you have created some definition for your request and response structures. You can just use this and import it. Now, XSD is a standard definition language for schema. Generally, nobody writes XSD, but if you're consuming an API and the publisher of that API has provided you with the XSD, you can use it. So let's give it a try. So we say import from XSD, and we'll pick the XSD file, and we'll say import. So now you will see that it has imported some structures, and it has picked up duplicate flag because that's how it was declared in the XSD. Let's quickly go and see what that XSD was. This is the XSD file. It's a little not so easy to read, but it clearly specifies exactly what your structure is. Right? Let's also go and, for example, we can delete it now. You can delete it from here. Now let's try importing from a sample XML. Now here you can either choose a file or you can copy paste. So let's do a copy paste. Okay. So now the same structure has been imported here. It's a different structure actually, but it has taken this XML and by example, as example, it has imported this. Here again, the name is captured as a duplicate because there were multiple instances of the member node in the example. Now, similarly, we can do import from sample JSON. Here again, you can pick a file or just copy paste. Okay. So this is how you would, in a typical situation, you would never create these tags by hand. You would just import it from some format that is already available with you. So this is how you go about creating your schema. Now you can also move the nodes around. You can just simply, if you want to move something up and down, let's say you want to take this and move it under the member node, you can, for example, take this and drop it under here. So you can pretty much move things around by dragging and dropping. You can access other things like you can clone. So for example, if you want to create a copy of this node, you can do a clone. And then you go there and change the name at least. And you can make other changes. Then you can also do a copy schema and paste schema. So for example, let's take this and do a copy schema. I can go somewhere else, and here I can say new tag. And here I can say paste schema. So the entire structure got copied here. So this is how you would build your schema. And response, like I said, by convention, represents the response of the APIs that you are writing. And the web service is by convention the request and response structures of the APIs that you're consuming. And in other parts of the how-to guide, you will see how we work with APIs and how we write and consume APIs. Okay. So for now, staying on the schema, let's discuss one more thing, which is that when you declare a structure, this is a declaration, which means you can actually start putting values into these nodes when you write the programs. Now, now what happens is sometimes you may want to use the same structure in multiple places. For example, let's say family is something that I'm going to use in a request, in a response, or in my local storage. Incidentally, the variables that you see here, this represents the local storage of your program. These are the global storage, and you use it exactly the same way as you use something else. You create a schema. So let's say I want to use this as a reusable structure so that I don't have to declare this every time. So what I would do is I would go on the types. And for example, I will create a new type. And here I'll say family member type. Now I can take this. So this is the member, actually the structure, ID, name, first name, last name. I can say copy schema. And here I can say paste schema. So now I have this family member type, which has an ID, name, and first name. Last name I had deleted. So first name title, for example, that's our structure now. Now I want to, for example, I can go back here and delete everything under it and give it a type which is TYP followed by name of the type, which is family member type. And I can leave the duplicates. And if I say save, now here, this family is of this type, but the entire structure you can see is available here. So these nodes actually don't exist here. They have been replicated, or sort of a shadow has been shown here, which is the declaration here. If I go back and change the type definition here, this will automatically reflect the changes. This is another reason why we use reusable structures. It's not just to save effort on typing, but also if the structure needs to undergo some change, you don't have to remember where all I have used it and change it in all those places. So this is a very simple, neat way of, and in a program, typically, this is how you should do. Declare all structures as types and then use them in your schema, wherever you feel. So these are the basics of the schema, and this will tell you how to create the elements and the structures. Now, how to use them? You obviously use them in your program. So when you start writing the APIs, we will see how we can reference an element, the path, if it's an array, or if you've used a key, how we can reference the hash table. We will cover it in a different section. Right now, before leaving, I want to talk about the database because that's also a very significant part of the schema. So here, let's say I want to create a table in the system. So first thing I will do is I can go to this tool called the DB Assistant. We have a lot of tables already existing here. So let's say I want to create a new table. I come here and I say create table. Now here I can choose the column. So for example, column name is ID, and then type is integer, and then add another one. Yeah, well, let's give it a size of 16. And I have to give a table name. Let's just, for simplicity, just use these two, and then I can say execute. Now you see that this A table has been created. And if I do a select from, I will get those fields and I can see what is in there. I can do an insert into, and here let's say ID is 1 and first name is Then I can go back to a select from, and here let's say select everything, and I don't apply a filter. I should get back what I had created. So these are the basic table operations, or how you would manage your database in Schema. And I only showed you this because I want to show you the next step, which is come back here. And here I can say now add a table. And here, okay, because I just created that table, I will need to, okay, this will get discarded because I will not save it. I will just reload the page. It's asking me if I want to resume. Okay, let's resume. We will get it all back. And now I can do a new database table. And here now I see this table name, the database name, and I can do a save. So now I have this table in my schema. And here I do import definition, which means now it has imported these fields from the physical database that exists on the server. So now from the designer, we launched the DB assistant, connected to the database, created a table, and added that to our project. And this also is visible to your program as a structure, which is or a schema. So as you see, everything else, everything here is just building up more and more schema elements. For example, cookies. If you want to have a cookie in your application, you just add a tag here, and that actually becomes a cookie. So let's say. It means that now if you put a value into this, system will treat as a request to create a cookie by that name. The variables are global variables. Session is your application session, which is you can control how you link to the session. You can either use JWT or cookie, which is what normally a Tomcat application uses. So this completes our definition or our discussion on the schema. Now, after you have go back and view this little tutorial, if you think you still have some doubts or gaps in your understanding, then come back and actually practice every step that we've discussed in a live environment. So thank you. This was all about schema.